Alright, let's pick back up at number 3. We're taking integration of um, x plus 5 plus 25 over x minus 5. So if we integrate it individually, we get what? Okay, and then we can look at the answers. We have 5 choices, and this is E. Okay. Alright, let's go to the next one. Alright, next one is number 4. Let's see, let me get this screen. Alright, we're going to continue with number 4. So two different functions, so we want to use integration by parts, but this one requires some tricks. Okay, so what we're going to do is let's go ahead and split them up. So let's do a u substitution. If I made u to be x squared, what would be u? It would be 2x dx. Okay. Now we will look up here, we have x cubed e to the 6x squared. So if we can bring in a 2x, so I'm going to take one of the x from the x cube, and that's the x dx, but I need a 2, so I'm going to take that 2 away by multiplying by half. Okay. Alright, now we're ready to make the change. So this is my du from here. I have x squared is my u, so this is u times e to the 6u and du. So now we can do integration by parts, which is u dv is uv minus integration of v to u. Okay. So since we already have u, let's make different letters. So let's make an a. So the part that is easier to differentiate, we'll make that a. So let a be u, and take derivative of that. dA has to be du. And let's make that other part dB. Okay. And let's make that e to the 6u du dB. So integrate that one. Integrate that one. What do we get? So instead of u and v, this is going to be a times b, and integration of b dA. Because I changed, because I already had u, so I'm making a and b. Alright, now we can go ahead and do the integration by parts. So that's going to be integration of this will be ab, or 1/6 u e to the 6u minus integration of v du, or integration of b dA. So that's going to be 1/6 to the 6u du. So now this is going to be and integration of this 1/6 outside this constant goes outside. Integration of e to the 6u, we know it's going to be another 1/6 e to the 6u. So we're essentially done here. Now we're going to just plug in what we have. Okay. And not forget to multiply by half. So let's go back where we started. We were here. So we can write integration of x cubed is 6 x squared dx will be half times all of that. Remember u was x squared. So almost done. Now multiply by half. What did I get? Wait a minute. Let's see. Sliding. 1/12 x squared e to the 6x squared minus 1/72 e to the 6x squared. Okay? Plus c. Now we can also factor out 1/72. And if we do that, what's left? Well, I took 1/72, that means I'm dividing this by 1/72, so there's 6 there. X squared e to the 6x squared minus e to the 6x squared plus c. So we could also factor out e to the 6x squared because it's here and here. I think this is as far as we need to go. Okay, and if you look at the question, the answer A, B, C, D, E, and answer is D. Okay? So this is D. And we're done with that one. Alright, number 5. It's a definite integral. And you know we're gonna have to do integration by parts because we have two different functions here. Right? So what would be a good choice for you? Well, I would choose u to be x and dv to be cosine 9x. Alright, and now we go ahead and take derivative of u. What's the derivative of u? Du, and derivative of x is dx. Now if I integrate cosine of 9x, what do I get for v? That's right, 1/9 integration of cosine 9x is sine 9x. Okay. Now uv minus v du. So integration of this, and we're going to put in the limits a little bit later. Okay. It's uv or 1/9 x times sine 9x minus v du. That means integration of 1/9 sine 9x dx. We'll continue here. What's the integration of sine 9x? Well, it is going to be 1/9 negative, because integration of sine is negative, makes this positive, cosine of 9x. Let's see. Well, we actually have definite limits. I wrote plus c here, but we have definite limits, so we're going to go ahead and rewrite this. And evaluate. From where to where? Pi over 9 to 0. Alright, so let's start plugging it in. Plug in. First I'm going to try pi over 9 for both of these terms. So I'll have 1 9 times pi over 9 times sine 9 times pi over 9 plus 1 over 81 cosine of 9 times pi over 9 or cosine of pi minus, now I'm going to plug in 0 for x Any questions? Okay, what is sine of pi? 0, that's right. So this goes to 0. This one stays. And what is this one? Cosine of pi is -1, so this is -1 over 81. Sine of 0 is also 0, so this one goes to 0. And by cosine of 0 is 1, so I have it's 2 of them. Okay. Alright, let's start with number 6. Number 6 looks like this. And this one we have to manipulate a little bit. So what I suggest you do is break up sine cube 2x as sine square 2x times sine 2x times cosine 4 2x dx, and then convert this sine square 2x into 1 minus cosine square x. So kind of the reason to do that is by the rules in your book, and also that anytime you're gonna take derivative integration of cosine, you're gonna have sine there for your u and du substitution, right? So we'll go ahead and multiply this out and distribute both of these to each one. So the first part will be cosine 4 2x sine 2x dx, and the second part will be cosine 6 2x sine 2x dx. Alright, so what do we have after that? This is actually like an example in your book. I think it's page 525, example 1, right? So now we can do u substitution. What if we let u be cosine of 2x? What would we do u? Positive or negative? Derivative of cosine is negative 2 sine 2x dx. So we can make this u substitution here and here, and if we do that, let's go into this. And we're bringing a negative, and make that cosine 2x to the fourth power. That's the first part. And I brought in a negative 2 sine of 2x dx. So let's see what we got extra. We had sine 2x, but a negative 2, so we gotta take away a negative half. Same thing here. We're gonna take out a one negative from here, and still take out a negative half. Let's see. Move this page over a little bit. Right here. Okay. So now we can go ahead and make the u and du substitution. So that'll be u to the 4 du. This whole part is du. And u is cosine, so we have fourth power. This one is positive, negative and negative is positive, half. Integration of e to the 6. And that from Cal 1 we know integration of that is what? Question. Alright. Now we got a little bit more to go here. So let's make this negative 1/10. Replace what our u was. U was cosine 2 to the 5th. This is 1/14 cosine 7 2x. Let's see. Alright, so we can take the common denominator of 10 and 14. That will be what? 70? Yeah. So what if I took out negative 1 over 70? What do we have left there? Well, since we also have cosine 5, we can also take a cosine 5. Well, this will be 7. Since I took a negative, this is positive. The next one will be negative. Negative what? Algebra skills, right? So it's going to be 5. And we're done with number 6. And let's look at the answers for 6. Is it A, B, C, D, or E? It's E. So choice E. Okay. Okay, let's move on to the next one. Okay, number 7 looks like this one. This is actually the easiest problem on this test. Okay. If you remember, what is the integration of, what is the derivative of tangent? To the higher. And if you recognize that derivative of tangent is secant square and it's right there, then you can go ahead and do this really fast. So we're gonna let u be what? Power. This is the higher power. So we're gonna let that be squared pi x over 2 times chain rule inside. Okay, so derivative of pi over 2, right? What is the derivative of pi over 2?
X.
Pi over 2x.
Am I-
It is pi over 2 on the outside. So we can write it as okay. So we look over here.
Notice
And we notice that sitting right there is that. The only thing that's missing is this. So we got to bring an extra pi over 2 and take that away. Okay.
is
First part. Second part. But since we have pi over 2 extra, how do we offset it? 2 over pi. So now this part is u cubed, because remember we made our u. And this part, just the u. And that gives us which is and we're going to start with u, so you got to back substitute. And remember our u was tangent pi x over 2. So this is tangent 4th power.
That's the
answer. Excuse me. Alright, so that will be what? A, B, C, D, or E. Never choice D.
like this.
Just like this.
And look at
In your book, section 8.4, page 533. Right, so this is the form that looks like this.
the next.
And if you have a form that looks like this, you have to do what?
Well,
Make substitution. What kind of substitution is good for
Wanna
you?
make-
Well, you want to make u be a sine theta. Okay, so let's take a look here. What is your u and a over here? Your u is 2x, your a is 7. Right?
U
So we're going to start with making let
is your
u
two.
is your 2x, a is 7 sine theta.
And
And then if I take derivative of both sides, we get that means dx is 7 half cosine theta. Okay, so now we can plug it back all in here. Okay, and also realize that if you draw the triangle from here, right, your sine theta will be 2x over 7. So if this is theta, which side is 7x and which one is 2? Which one is 7, which one is 2x? Okay, look at the x. Well, 7 will be a hypotenuse, and 2x will be your opposite. If that's the case, your adjacent will be exactly what you have here. So this is kind of a checkpoint to see if you
your assumptions are kind of correct. Okay. All right. So let's go ahead and replace what we can replace and see what we have. Okay. So this one is we made 2x into 7 sine theta. So this is going to be 49 minus 49 sine squared theta from our assumption. And we know dx is going to be 7.5 cosine theta. So if I factor out at 49, can I write 1 minus sine squared?
7 is 4.
So what's next? Square root of 49 is 7. 7 times 7 is 49. We can take that 49 over 2 outside. What is square root of 1 minus sine squared theta? It is cosine theta. Cosine theta. And this is just think about cosine squared theta, d theta. We know cosine squared theta.
Double. Do we make this?
One of the identities is 1 plus cosine 2 theta over 2, right? We've used that in class a lot, right? So if I replace this by that, this becomes so the question is, why do we make this change? Well, we made this change for what? For ease of integration. Ease of integration. Now if I integrate this one, I get integration of integration of cosine 2 theta, sine 2 theta. Do we know something about sine 2 theta? That's right. It is 2 sine theta times cosine theta. Right? Double angle measure. Right? All right. Now what we're gonna do is we're gonna back substitute for theta from this triangle. So if you may need to draw the triangle again to make sure. Alright, so if you remember, we assumed 2x was 7 times sine theta. So if I solve for sine theta, from there, it's 2x over 7. So first part, theta will be arcsine (2x over 7). Okay, let me know. Check your understanding on that, right? So this is from here, so theta will be sine inverse 2x over 7. Right, now to the next part. 49 times 4, 49 over 4 times 2, that's from this 2. What is sine theta? 2x over 7. What is cosine theta from this triangle? Adjacent over hypotenuse. So that's this guy. And what is that? 7, sorry. 7, Alright, so tell me what can.
Okay. Mistake here.
Slight
2
mistake.
theta.
Cosine 2 theta.
Integrate that. That's how right.
Yeah, that's half sine 2 theta. So that's what I was looking over it. So you have an extra half here. This half and 2 cancel out, and on this step this becomes 49 over 4 arc sine 2x over 7 plus cancel, 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 cancel. So it'll be x times square root of 49 minus 4x squared over 2 plus c. Okay. Let's look at the choices.
C, D.
A, B, C, D, or E. And this one is C. Okay. Moving on to number 9. Okay. Here's number 9. Alright, take this page away. Scroll it down so you can see it. Number 9 is
This one was
square root of 1 minus e to the 4x dx. Okay, so this is sort of a problem from the book. Kind of like number 31 on section 8.4. 31 on section 8.4. Okay, so how do we
compare
well, you
A
have to
square.
compare it to the standard forms we have, right? If you look back at trig substitution, if you have a square root of u square minus
F of
u
that.
square format, that's u substitution for sine theta, remember? So that's what we're going to do here. Okay, so we're going to let we're going to let e to the we're going to let e to the 2x become for you. Well, that would be sine theta. And then take derivative of this. What do we get? 2 e to the 2x dx is cosine theta d theta. Okay. So now we can look over here and see that we have this
Here and
here and here. So this is something extra we're going to bring in. Okay. Okay. So I'm going to write 2 and take away that 2 by multiplying by half. So we know this is going to be cosine theta
D
d theta. And this is going to be okay. Right. So now what? Well, we know 1 minus sine squared theta is cosine squared theta. Take square root of that. We have cosine theta times cosine theta
done with
d theta. So that is nothing but cosine squared theta d theta. Just use this one in the last problem, remember? From identity. Okay, so this becomes 1/4 and integration of that will be extra line here. All right. 1/4 theta plus 1/2 sine 2 theta plus c. Right. Now what is sine 2 theta double angle measure? Right. So this is gonna be but we did not
Right.
start with theta. We started with x, right? So we're gonna draw the triangle. Remember our first assumption was e to the 2x is sine theta. So if this is theta, that means what? Opposite of hypotenuse. This is gonna be opposite. Hypotenuse is gonna be 1, and this is gonna be exactly what we had before. Right? Now we're just gonna plug in sine theta, cosine theta, and theta itself. What is theta gonna be? That's right, arc sine e to the 2x. Okay? I'll multiply by 1/4, and then sine theta we know is e to the 2x. What's going to be the cosine theta? Well, adjacent over hypotenuse. So that's just going to be square root of 1 minus e to the 4x plus c. So that's your answer. Okay, so what is that choice? A, B, C, D, or E? Let me see. It's A, right? All right. So, question. I'm sure I'll get questions later. Okay. All right. Let's go on to the next one.
Alright, let's go to 10. 10 is probably the easiest problem. We have to partially decompose 4x squared plus 3 over x plus 8 cubed. And if we partially decompose it, we know it's not a quadratic, so we have to go from the lowest power of 1 and get to 3. So it's a over x plus 8, b over x plus 8 squared, and c over x plus 8 cubed. Easiest problem on this test. Okay, so the answer is choice A. Alright, let's move to problem number 11. Right? So problem number 11, obviously we're going to do partial here. So how can we factor this thing out? And if this works. It does. So we're going to decompose it as so multiply both sides by common denominator. We multiply those two, we get that. So this is going to be 8 times x plus 1 plus b times 4x plus 1. Right? So multiply by common, which is so now we can do it two different ways. I'm gonna do it the way breaking it up, distributing, taking your x's together, and putting your constants together. Okay. Since there's no x terms here, think of the x term being 0. So a plus 4b has to be 0. The other one, a plus b, has to be 3. Okay. So we can use those two to find the solution here. So I'm gonna just substitute a is negative 4b into here. So I found b to be negative 1. If b is negative 1, a is to 4. Alright, so now let's go back to the integration. Integration is 2 to 0 of s which we found to be minus. Now we can integrate this one. Okay. What's the integration of 4 over 4x plus 1? Well, by u substitution, we let u be 4x plus 1. Du will be 4dx, and 4 is sitting out there, dx. So it will be du over u, or ln of 4x plus 1. And this will be ln of x plus 1, all from 2 to 0. So since this is definite, we gotta plug in the values and go from there. When I have ln of a minus ln of b, can I not write it as this? As division. Okay. So we can plug in 2. We'll plug in 2. 2 times 4 is 8, plus 1 is 9. So it's 9 over 3 for the first part. Plug in 0, I get 0 here, 0 here, so it's ln of 1. ln of 1 is 0. So this is ln of 2. So this one is which one? A, B, C, or D, or E? Choice is B. Okay. Alright, let's go to 10. 10 is probably the easiest problem. We have to partially decompose 4x squared over 4x squared plus 3 over x plus 8 cubed. And if we partially decompose it, we know it's not a quadratic, so we have to go from the lowest power of 1 and get to 3. So it's a over x plus 8, b over x plus 8 squared, and c over x plus 8 cubed. Easiest problem on this test. Okay, so the answer is choice A. Right, let's move to problem number 11. Right, so problem number 11, obviously we're going to do partial here, so how can we factor this thing out? And if this works, it does. So we're going to decompose it as okay. So multiply both sides by common denominator. We multiply those two, we get that. So this is going to be 8 times x plus 1 plus b times 4x plus 1. Right? So multiply by common, which is so now we can do it two different ways. I'm going to do it the way breaking it up, distributing. Taking your x's together and putting your constants together. Since there's no x terms here, think of the x term being 0. So a plus 4b has to be 0. The other one, a plus b, has to be 3. Okay? So we're going to use those two to find the solution here. So I'm going to just substitute a is negative 4b into here. So I found b to be negative 1. If b is negative 1, a is let's do 4. Alright, so now let's go back to the integration. Integration is 2 to 0 of this, which we found to be minus. Now we can integrate this one. Okay. What's the integration of 4 over 4x plus 1? Well, by u substitution, we let u be 4x plus 1. Du will be 4 dx, and 4 is sitting out there, dx. So it will be du over u, or ln of 4x plus 1. And this will be ln of x plus 1, all from 2 to 0. So since this is definite, we gotta plug in the values and go from there. When I have ln of a minus ln of b, can I not write it as this? As division. Okay. So we can plug in 2. We'll plug in 2. 2 times 4 is 8, plus 1 is 9. So it's 9 over 3 for the first part. Plug in 0, I get 0 here, 0 here, so it's ln of 1. ln of 1 is 0. So this is ln of 2. So this one is which one? A, B, C, or D, or E? Choice is B. Okay.